Hello, my name is Deborah Gaborik-Snyder. I'm 3M Business Development Manager for the Sign Management System. I'm here today to present on the FHWA ruling and sign management. In May, the FHWA published their final ruling on the minimum retroreflectivity standards. The updated ruling requires implementation of an assessment and/or management method to maintain the minimum levels of retroreflectivity for regulatory and warning signs by June 2014. It eliminates compliance dates for various sign types not meeting the minimum levels. But even without these dates, agencies are still expected to prioritize the replacement of non-compliant signs based on various engineering considerations. It also states that guide and street name signs are to be added to an agency's assessment and/or management method as resources allow. And it exempts historic street name signs from the required MUTCD standards. The FHWA has identified 3 management methods and 2 assessment methods that agencies can use to maintain their regulatory and warning signs to the minimum levels of retroreflectivity. Management methods allow agencies to maintain sign retroreflectivity without having to assess individual signs. A sign inventory is not required by the MUTCD, but it might be beneficial to an agency. Sheeting type must be known if a management method is used. The first management method is control signs. This is a replacement of signs in the field based on the performance of a set of sample signs. These control signs can be in a maintenance yard or a selection of signs in the field. And all signs represented by a specific set of control signs should be replaced before the retroreflectivity of the control signs reach the minimum levels. The advantage? It's less costly and time-consuming than monitoring all signs in the field. The disadvantage is that an agency needs to create and set up the appropriate control environment. The next is blanket replacement. All signs in an area or corridor or of a given type should be replaced at specific intervals based on the expected sign life for the shortest life material used. The advantage? There's no need to track signs or assess retroreflectivity. It's really the easiest method to manage. But the disadvantage? An agency may be replacing good signs that do not need to be replaced. The final management method is expected sign life. This uses installation dates of signs so that the age of any given sign is known. The age of the sign is compared to the expected sign life, and signs older than the expected life should be replaced. The advantage? It's very easy to use and plan for replacement. But the disadvantage is it doesn't consider that signs may fail earlier or last longer. And it also assumes that the installation date of each sign is known. The first assessment method is measured retroreflectivity. Each sign's retroreflectivity is measured using a retroreflectometer, and those below the minimum level should be replaced. The advantage? It's extremely accurate, but the disadvantage is it's an annual process. There's a large time and resource commitment that needs to be made by the agency. The signs must be cleaned properly, multiple readings taken per color, and then an average must be calculated of all the readings. For the nighttime visual assessments, the retroreflectivity of an existing sign is assessed by a trained sign inspector following a formal visual inspection procedure from a moving vehicle during nighttime conditions. Signs that are visually identified by the inspector to have retroreflectivity below the minimum levels should be replaced. The first assessment method is measured retroreflectivity. Each sign's retroreflectivity is measured using a retroreflectometer, and those below the minimum levels should be replaced. Advantage? It's extremely accurate. But the disadvantage? It's an annual process and a large time and resource commitment by the agency. The signs must be cleaned properly, multiple readings taken per color, and then all those readings averaged to come up with one reading per sign. For nighttime visual assessments, The retroreflectivity of an existing sign is assessed by a trained sign inspector following a formal visual inspection procedure from a moving vehicle during nighttime conditions. Signs that are visually identified by the inspector to have retroreflectivity below the minimum levels should be replaced. The first visual nighttime assessment method is consistent parameters. This is where nighttime inspections are conducted under similar factors that were used in the research to develop the minimum retroreflectivity levels. An SUV or pickup truck, model year 2000 or newer, must be used. The inspector must be at least 60 years old. Signs are viewed at typical viewing distances, and any signs not legible to the inspector should be replaced. Next is a comparison panel method. Small comparison panels are used to assess the retroreflectivity of questionable signs. The panels are fabricated at or above the minimum levels. When a sign's retroreflectivity is uncertain, a comparison panel is attached to the sign and viewed by the inspector. If the panel appears brighter than the sign needs to be replaced. The final method is calibrated signs, where an inspector views a calibration sign prior to conducting nighttime inspections. These signs have known retroreflectivity levels at or above minimums. The signs are set out where the inspector can view them in a manner similar to nighttime field inspections. Signs are needed for each color of sign in the table 2A-3 on minimum retroreflectivity levels and sheeting type. Signs are viewed at typical viewing distances, and signs must be properly stored to prevent deterioration, and their retroreflectivity level should periodically be checked. Other methods based on engineering studies can be used by agencies as long as they're documented in an engineering study and correspond to the values in Table 2A-3. One such method is mobile retroreflectivity, which takes measurements while driving at night. This method is better in areas of less ambient light and longer viewing distances. It's good for large sign populations and overhead signs. But there are challenges for the system with smaller narrow legends or signs using prismatic sheetings or in urban environments. It minimizes subjectivity but does not eliminate torque potential. The advantage of all the visual nighttime assessment methods is that they're quick and inexpensive. The disadvantage is they may need to be conducted annually, and they're not 100% accurate. There was recently a survey done of 49 agencies, and they were asked what are their primary sign replacement methods and what's their secondary or support method. The majority of the agencies responded that they use expected sign life, followed by nighttime inspection. A 3M perspective. 3M has been in the traffic safety business for more than 75 years, and it understands the performance factors of sheeting better than most companies in the industry. We've spent decades collecting weathering data from around the world on its performance. This gives 3M a unique perspective on sign management. Over the years, 3M has spoken with many agencies worldwide, trying to understand their needs and challenges with sign management. The message was clear. Solutions should be from the traffic engineer perspective and provide tools to manage signs on a daily basis, making the agency self-sufficient and allowing for future planning and budgeting. Also, using state-of-the-art Esri-based GIS technology was key. It allows data to be used by other agency asset management systems without putting additional strain on limited IT or GIS resources within the agency. Based on voice of the customer data and our own sign management projects, we have found that agencies want to have an initial inventory. This is done by doing data capture. The method most preferred is mobile data capture. These video logs are then viewed by technicians who then process those photos into actual data records for signs and posts. As records are being built, a daytime condition assessment of those signs and posts is also recorded. Once the data records are built, they need to be housed someplace. Agencies choose either web-based systems or off-the-shelf software to house this data. After the data has been built and uploaded to the system, a nighttime assessment should be conducted as part of a management system in order to determine how the sign performs at night and to be in compliance with the FHWA minimums. A field tool is then used by crews to record maintenance activities in the field and then transmit those results to the database. The database and system itself would not be complete without management tools that allow for queries, running reports, analysis, and planning. Key elements of an effective sign management system are being able to use the data to determine the service level or resources that are needed to keep the inventory current, conduct a condition assessment during field crew's normal maintenance activities to ensure signs are performing properly for drivers during the day, identify signs that need to be replaced and budget for their replacement, comply with the FHWA retroreflectivity requirements, and gradually move to a sign life prediction model, implement a disaster recovery plan in case of a catastrophic event, such as a tornado or flood. And why are these elements important? Because what a driver sees during the day may not be the same as they see at night. There are various features that we have heard agencies want in a sign management system. They want something that's intuitive and easy to use on a daily basis by their sign crews. They want detailed information about each post and all the signs associated with that post, along with photos. They want traffic planning tools, traffic engineering planning tools, so that engineers can actually plan out what work has to be done, where it is to be done, and whether traffic control is required. They want the ability to query the data based on specific criteria, generate standard and custom reports, and be able to download those into PDF files or even Excel spreadsheets. A field tool is another requirement that allows the crews to communicate real-time with the main office while on site. A work order system to record the work that was done, by whom, and when. Also paperless, so that's environmentally friendly. A sign life prediction model, and the ability to integrate with other agency systems such as enterprise asset management, financial, or inventory. Best practices for an agency to consider would be choosing a nighttime assessment with comprehensive maintenance approach initially, then gradually migrate to an expected life method using some level of predictive modeling for sign service life. This will help an agency minimize startup costs. Also use a GIS-based inventory and a GPS-enabled field tool. Initially, only collect necessary attributes. Do not try to collect other attributes that may add cost and overburden the system, such as sign installation date or sheeting type. Establish a method and process that conform to an agency's current daily maintenance and installation routines. This will help establish initial compliance. And finally, use a centralized GIS database and management tool to turn the data into information that allows an agency to make decisions based on facts. This will allow an agency to be self-sustaining into the future. So how long does a traffic sign actually last in the field? Well, the answer is it depends, as there are other factors affecting its performance. Although much attention has been given to FHWA minimums of retroreflectivity over the last few years, how a sign functions at night, visibility, and legibility is only part of the story. 3M reviewed data from our sign management projects completed during 2011 and was very surprised to find that on average less than 1% of the total signs within each project had defects related to retroreflectivity. Based on our data, approximately 7.5% of an agency's sign population received a rating of either fair or critical as to its overall performance level as identified during daytime and nighttime assessments. The major factors affecting a sign's visibility or legibility are fading, graffiti, stickers, obstruction, contrast, damage. All of these defects occur as often or more often than a sign not meeting the required minimum levels of retroreflectivity. For an agency to have a complete picture of how well its signs are performing for the driving public, a daytime and a nighttime assessment should be conducted as part of the initial sign management project. Besides agency resources, funding is probably the largest hurdle an agency has to overcome in implementing a sign management system. With agencies doing more with less, finding a way to initially fund a project may be impossible. There may be some resources available to agencies through the following federal aid programs to help defray costs associated with compliance. These are local metropolitan planning organizations, or MPOs, state DOTs, and even the state FHWA office. There are also some programs that may help fund the sign management system. State Planning and Research Program, Community Safety Grants, and the Highway Safety Improvement Program, or HSIP. There's also funding available for sign replacement from the National Highway System, Surface Transportation Program, Interstate Maintenance Program, HSIP, and high-risk rural roads. Thank you for your time, and I hope you found the presentation informative. To learn more about how 3M can assist your agency with sign management solutions, please stop by our booth or email me at dgaborik@mmm.com. Again, thank you, and enjoy the rest of the conference.